You open your Windows 11 laptop, you check your storage, and the numbers do not add up. You have a 512 gigabyte SSD, your files take up maybe 80 gigabytes. Your installed programs take up another 60. That should leave you with over 350 gigabytes free. Instead, Windows is showing you 180 gigabytes available, maybe less. Somewhere between what you can see and what you have, Windows 11 has quietly consumed over 100 gigabytes of your storage for purposes that were never explained to you. In files and folders that are hidden from view by default, running processes that most users have no idea exist. This is not a bug, this is by design. Windows 11 reserves storage for system functions, compatibility layers, update infrastructure, hibernation states, virtual memory, and component backups. And none of this is communicated clearly to the person who bought the drive. On a 256 gigabyte SSD, where every gigabyte genuinely matters, the difference between what Windows shows you and what Windows is actually using can be the difference between a computer that works and one that constantly runs out of space and slows to a crawl. In this video, I'm going to show you exactly where every hidden gigabyte is going, exactly how to get the safe ones back, and exactly which ones you should leave alone and why. By the end, you will have a complete picture of your storage situation that Windows 11 never bothered to give you, and you will have reclaimed meaningful space without touching anything that could cause problems. Let us start with the biggest hidden consumer of storage on most Windows 11 systems, and it is one that almost nobody knows is there because it does not appear in File Explorer under normal settings. It is called hyberfill.sys, and on a machine with 16 gigabytes of RAM, this single file is quietly consuming between 6 and 16 gigabytes of your SSD, depending on how Windows has configured it. On a machine with 32 gigabytes of RAM, it can be even larger. Hyberfill.sys is the hibernation file. When you hibernate your computer, as opposed to putting it to sleep, Windows takes everything that is currently in your RAM, writes the entire contents to this file on your SSD, and then powers the machine off completely. When you turn it back on, Windows reads hyberfill.sys and restores your session exactly as it was. The reason the file is sized to match your RAM is that it needs to be large enough to store the entire memory state of a fully loaded system. Windows also uses hyberfill.sys for a feature called fast startup, which is enabled by default. Fast startup is not a full hibernate, but a partial one. When you shut down Windows with fast startup enabled, Windows saves the kernel session state to hyberfill.sys so that the next boot can skip certain initialization steps and load faster. The reason hyberfill.sys does not appear in your storage usage is that it is a protected operating system file, hidden from File Explorer by default. You can only see it by going to File Explorer, clicking the ellipsis at the top, selecting Options, navigating to the View tab, enabling Show Hidden Files and Folders, and unchecking Hide Protected Operating System Files. When you do that and look at your C drive, hyberfill.sys appears and its size will likely surprise you. Now, what should you do about it? The answer depends on how you actually use your computer. If you never use hibernation, you either sleep your computer for short breaks or shut it down fully. Hyberfill.sys is providing you zero benefit while consuming significant storage. You can remove it entirely by opening a command prompt with administrator rights and running the command power cfg h off. This deletes hyberfill.sys immediately, disables hibernation, and also disables fast startup as a consequence. On a modern NVMe SSD, the difference in boot time between fast startup enabled and disabled is typically just a few seconds, barely perceptible. On older SATA SSDs or hard drives, the gap is more noticeable. If you travel with a laptop and genuinely use hibernation to preserve your work session across multiple days without battery drain, keep hyberfill.sys. If you do not, reclaim the space with a single command and never think about it again. The second major hidden storage consumer is called pagefile.sys, and it is Windows 11's virtual memory system. When your computer runs low on RAM, when you have too many programs open and physical memory fills up, Windows begins moving portions of memory contents that are not actively being accessed out to pagefile.sys on the SSD, freeing up physical RAM for the programs that need it most. This process, called paging, is slower than using actual RAM because SSD access speeds, while fast, are orders of magnitude slower than RAM access speeds. Pagefile.sys is automatically sized by Windows based on your installed RAM, typically between 1.5 and 3 times the size of your physical memory, though Windows adjusts this dynamically. On a machine with 16 gigabytes of RAM, pagefile.sys might occupy anywhere from 4 to 12 gigabytes, depending on your usage patterns and how aggressively Windows has configured it. Like hyberfill.sys, it is a hidden system file invisible in File Explorer under default settings. You can see its current size and reconfigure it by right-clicking the Start button, selecting System, clicking Advanced System Settings, going to the Advanced tab, clicking Settings under Performance, clicking the Advanced tab in that window, and then clicking Change under Virtual Memory. This interface shows you the current size of the page file and lets you configure it manually. For users with 16 gigabytes or more of RAM who do not run memory-intensive workloads, you can often reduce the maximum page file size meaningfully. However, be cautious here. Setting the page file too small on a system that does occasionally need virtual memory can cause application crashes or system instability. If your machine has 32 gigabytes or more of RAM and you do not run memory-intensive applications like video editing or virtual machines, you can reduce the maximum size more aggressively. If you have 8 gigabytes or less, leave Windows managing it automatically. The third hidden storage consumer is the one that tends to shock people most when they first see the actual numbers, the WinSxS folder, also called the Windows Component Store. WinSxS lives inside your Windows folder, and if you navigate to it in File Explorer and check its properties, the size that Windows reports will be enormously misleading, often showing 20, 30, or even 50 gigabytes. The reason it appears so large in File Explorer is that many of the files in WinSxS are hard links, Windows pointers, that make files appear to exist in multiple locations simultaneously, but actually only occupy storage space once. The WinSxS folder holds multiple versions of Windows system files, older versions of system components, rollback data for updates, and compatibility files that allow Windows to restore to previous states if an update causes problems. After a major Windows feature update, WinSxS often contains substantial amounts of genuinely reclaimable space, the old version of Windows components that existed before the update, and that you no longer need if the update has been running stably. The safe way to clean this up is through the Deployment Image Servicing and Management tool, known as DISM. Open a command prompt with administrator rights and run DISM online, clean up image, analyze component store. This command examines the component store and tells you how much space can actually be reclaimed. If the analysis reports reclaimable space, run the follow-up command dism online / cleanup image start component cleanup. This removes the superseded versions of components that Windows no longer needs. After major Windows updates, this single command regularly returns multiple gigabytes of space on typical systems. Do not attempt to manually delete files from WinSxS or modify it through File Explorer. The hard link structure means manual deletion often fails silently or breaks system references. DISM is the correct and safe tool. It is built into Windows, and it does the job without risk of damaging the operating system. The fourth hidden storage category involves Windows update files in the previous Windows installation folder. After Windows 11 installs a major feature update, it keeps the previous installation files in a folder called Windows, old for a period of time, by default 10 days, to allow you to roll back if the update caused problems. After that 10-day period, Windows is supposed to clean up Windows old automatically. But on many systems, it lingers considerably longer, consuming anywhere from 12 to 30 gigabytes of space. Similarly, Windows Update maintains a cache of downloaded update files in a folder called Software Distribution, and this cache can accumulate to a significant size over time. The safe way to clean both of these is through disk cleanup run with administrator rights. Press the Windows key, type disk cleanup, right-click the result, and select Run as Administrator, then click Cleanup. System files when the initial scan completes. This reveals the system-level cleanup options, including previous Windows installations and Windows Update Cleanup. Both are safe to select and remove. Alternatively, Storage Sense in the Settings app under System, then Storage can be configured to automatically clean up Windows Update files, temporary files, and the recycle bin on a schedule you define, enabling Storage Sense and setting it to clean up. Previous Windows installations after 30 days is a simple set and forget approach that prevents this accumulation from recurring. The fifth hidden storage category is System Protection and Restore Points. Windows 11 enables system protection by default on the C drive, which creates periodic snapshots of system files called restore points that allow you to roll the system back to a previous state if something goes wrong. Restore points accumulate over time, and the system protection feature is configured by default to use up to a certain percentage of your drive, which, on a 256 gigabyte SSD, can represent a substantial storage reservation. To see and manage this, right-click the Start button, select System, click System Protection, select the C drive, and click Configure. The slider controls how much disk space System Protection can use for restore points. On a large SSD, you may find it reasonable to keep this at 3 to 5%. On a smaller drive, you may want to reduce it further or clean up existing restore points by clicking the Delete button, which removes all existing restore points except the most recent one. Be aware that deleting restore points removes your ability to roll back to those specific system states. It is a trade-off between storage space and recovery flexibility. If your system has been running stably for months and you have a recent restore point from the last few weeks, cleaning up older ones is reasonable. The sixth hidden consumer is delivery optimization, which is Windows 11's peer-to-peer update distribution system. Windows 11 can download portions of updates from other Windows computers on your local network or from the internet, a system designed to reduce Microsoft's server load by having PCs share update files with each other. As part of the system, Windows caches update files locally that it may share with other computers. This cache can accumulate to several gigabytes, and it sits in a folder that is not visible through normal storage reporting tools. You can manage this by going to Settings, then Windows Update, then Advanced Options, then Delivery Optimization, then Advanced Options again. Here you can set limits on how much space the Delivery Optimization cache is allowed to use and manually trigger a cache cleanup. Alternatively, running disk cleanup with administrator rights and selecting Delivery Optimization files in the cleanup list removes this cache directly. The seventh and most thorough way to understand exactly where every byte of your storage has gone is to use a disk space visualization tool, because Windows 11's built-in storage reporting genuinely cannot show you everything. The free tool WinSxS is the fastest and most thorough disk space analyzer available for Windows. It scans your entire drive in seconds by reading the master file table directly rather than traversing the file system, which is how it can process an entire SSD in under 10 seconds, where other tools take minutes. WinSxS shows you a visual tree map of every folder and file on your drive ordered by size, including the hidden system files and folders that normal Windows tools obscure. Using WinSxS, after you have run through the cleanup steps in this video, lets you verify exactly how much space you have reclaimed and identify anything remaining that might be using unexpectedly large amounts of storage. Download it only from WinSxSFreeware.com, which is the official site. It is completely free for personal use and has been continuously maintained and updated. Run it as administrator to see the complete picture, including protected system files. Here's the realistic expectation of what all of this work adds up to. On a typical Windows 11 installation that has been running for a year or more, reclaiming space from Hiberfil.sys, running DSM component cleanup, removing Windows Update cached files and Windows.old, and managing system protection restore points together regularly returns between 20 and 60 gigabytes of storage. On a machine that has been through several major Windows feature updates without any manual cleanup, that number can be considerably higher. The Make Use Of investigation from early 2026 that found over 50 gigabytes of ghost files on a single SSD found the storage split across exactly these categories: Hiberfil.sys, WinSxS custom component data, update cache files, and restore point storage that had accumulated over years of normal use without any cleanup. None of this requires third-party optimization software, registry cleaners, or any tool that makes vague promises about improving system performance. Everything described in this video uses built-in Windows tools or the free WinSxS disk analyzer. And every step includes a clear explanation of what you are removing and what the trade-off is, so you can make an informed decision, rather than blindly running a cleanup that might remove something you actually needed. Let me go deeper on a few of these areas because the surface level explanation leaves out some important nuance that changes how you should approach the cleanup. On the Hiberfil, that is questioned specifically, there is a middle path that most guides do not mention, reducing the Hibernation file rather than eliminating it entirely. If you do occasionally use Hibernation or fast startup, but you want to reclaim some of the space Hiberfil.sys occupies, Windows offers a command that shrinks the file to a reduced size rather than deleting it completely. Open a command prompt with administrator rights and run powercfg-h, type reduced. This command reduces Hiberfil sys to approximately 40% of its full size while preserving the ability to use fast startup. Full hibernation, saving your entire session and powering off completely, will no longer work after this change, but the fast startup acceleration on boot time is preserved. For users who use fast startup but never actually hibernate their computer for days at a time, this is the best of both options. Smaller file, retained boot speed benefit. The WinSxS cleanup through DSM also has a more aggressive option worth knowing about, and it comes with an important caveat that you need to understand before deciding whether to use it. The command DSM online, or ARM cleanup image, start component cleanup, belongs in reset base, removes not just the immediately superseded component versions, but also the rollback infrastructure that would allow you to uninstall the most recent Windows updates. Without this rollback data, if a recent Windows update causes a problem, you cannot uninstall that specific update through the Windows Update interface. The cleanup returns considerably more storage than the standard start component cleanup command, often several additional gigabytes, but it is irreversible. The rollback capability is gone until the next update cycle creates new rollback data. The recommendation here is clear. Only use .reset base. If your system has been running stably for at least 30 days after the last major update, you have a full system backup, and you genuinely need the storage. If any of those conditions are not met, the standard start component cleanup without or reset base is the appropriate choice. The additional gigabytes are not worth losing rollback capability on a system that may still need to recover from a problematic update. The Windows Installer folder at C Windows Installer is a category that deserves special mention because it is one of the largest hidden storage consumers that is also the one most likely to be accidentally damaged by people trying to reclaim the space. The Windows Installer folder caches patch files and installer packages for every MSI-based application installed on your system, Microsoft Office, Adobe products, Visual Studio, SQL Server, and many other enterprise and professional applications. These cached files are used when you need to repair, modify, or uninstall those applications, or when Windows needs to apply additional patches to them. The folder commonly reaches 10, 20, or even 30 gigabytes on systems with many large MSI-based applications installed. The critical warning here is that you should not manually delete files from C Windows Installer. Windows has no mechanism for reconstructing these files after deletion, and deleting them will break the ability to repair or uninstall the applications they belong to, sometimes in ways that are not immediately apparent and only surface when you try to uninstall or update an application months later. The safe approach for this folder is to use a dedicated tool called Patch Cleaner, which identifies orphaned installer files, cached patches for applications that are no longer installed, and safely removes only those files while leaving the files needed by currently installed applications untouched. Patch Cleaner is free and available from its official developer's website. On a system that has had many applications installed and removed over the years, Patch Cleaner can reclaim several gigabytes from the installer folder safely and without risk. The reserved storage feature that Microsoft introduced in Windows 10 and carried into Windows 11 is worth knowing about as context for why your available storage always seems lower than expected on fresh installations. Microsoft deliberately reserves approximately 7 gigabytes of storage on every Windows 11 installation that is used specifically to ensure Windows always has space available to install updates, apply patches, and perform maintenance operations. This reservation cannot be removed through normal means. It is a built-in allocation that Microsoft designed to prevent the situation where a Windows update fails because there's not enough free space on the drive. You can verify whether reserved storage is enabled by running WinVer to confirm your Windows build and then checking via PowerShell with Get Windows Reserved Storage State. While this reservation is frustrating on small drives, Microsoft's reasoning is sound. Failed Windows updates due to insufficient disk space were a significant support burden and a source of system instability for many users. The reserved storage is effectively insurance against that failure mode. Accept it as a fixed cost of running Windows 11 and focus your cleanup efforts on the areas described in this video where the storage is genuinely recoverable. One more area worth a quick mention is the temp folders, both the system level C Windows temp and the user level temp folder accessible by typing %temp% in the run dialog. Applications create temporary files constantly during installation, processing, and crash logging, and frequently never clean them up. On a system unused for a year without cleanup, both temp folders together commonly contain between 2 and 10 gigabytes of orphaned files. The safe approach is to close all running applications, open each temp folder, select all contents, delete them, and skip anything Windows reports as currently in use. Disk Cleanup also handles this automatically. The Temporary Files option in Disk Cleanup clears both locations safely. When you combine all of these cleanup steps, disabling or reducing hyberfill.sys, running DISM component cleanup, removing Windows Update cached files and Windows.old through Disk Cleanup, managing system protection, restore point allocation, clearing delivery optimization cache, running Patch Cleaner on the Windows Installer folder, and clearing the temp folders, the total storage reclaimed on a typical Windows 11 system that has been in use for a year or more is typically between 30 and 80 gigabytes. On machines that have been running since Windows 10 and upgraded in place to Windows 11 over multiple feature update cycles, the number can be considerably higher. None of this requires spending money. None of it requires third-party optimization software with vague promises and questionable registry cleaning features. Every step uses either Windows built-in tools or 2 specific free utilities, WizTree for visibility and Patch Cleaner for the installer folder, downloaded from their official sources. The storage was yours when you bought the drive. Now you know exactly where Windows put it and exactly how to get it back.